Well, welcome. So how many are actually using Talend today? I want to know, who's my audience? Okay, Talend. We got lots of Talend folks here. Good. Well, it makes sense. It's a Talend users group. All right, and we're here in New York, and let's make one thing perfectly clear. I'm from California, but I love New York. I love New York City in particular. Today, we're going to try and blaze through about 2.5 hours of material in about 90 minutes. All right, so it'll be a short version. But I do want to encourage questions, and I'll probably just leave out a bunch of the stories that I usually share, customer examples, things like that. But this is really the second half of the job design patterns and best practices material that we've created. How many have seen the first half? So you weren't here for our very first one up at Fordham University?
Yeah, I missed the video.
The video, okay. So that's where I was going next. So if you haven't seen them, there's actually 4 one-hour webinars on parts 1, 2, 3, and 4 that are available to you to watch online. We're going to be covering parts 3 and 4 today. Total 32 best practices with Talend are included in this material. It's all focused on data integration. So if you got big data questions, let's table that for another conversation, or things about Spark and data streams and all that good stuff. But today we're going to focus on DI, data integration, best practices. And it all came about because of a series of blogs that I wrote when I joined Talend, and it's evolved into these webinars, into these boot camps and user groups, and it's been very widely adopted by our customers worldwide. So I'm glad to see that adoption. So a more formal introduction. My name is Dale Anderson. I'm now the regional manager of the Customer Success Architecture Group. Basically what we do is fill the gap between technical support and professional services. We're all senior, seasoned systems architects that have been around the block a few times, maybe a few more times than we'd like. But I've actually been working with Talend software since 2009, way before I joined Talend. I was an independent consultant. I found Talend. It allowed me to leave Informatica behind. I was very happy about that. So been actually at it since version 3.2, to give you some perspective. We're at version 7 now. Okay, so it's been a while. I joined Talend about 1.5 years ago, and it was the second CSA to join the company. My boss, Arshad Bertali, is the first, and we've grown now. I have a team of 6 here in the US, and we're almost 20 globally. So we have seen tremendous growth. I think that means that the CSA team is providing some value, and hopefully an event like this is the reason why. That's why I'm here. Okay, so this is meant to be an open conversation. Right? I'm going to give you some information, but I really want a conversation. So ask me any questions, interrupt me at any time. I'm okay with that. Okay? Give me a specific issue or problem that we need to sort out. We may take it offline, but if it's pertinent, definitely. Let's have a conversation today. And we're going to dive right in. In fact, I always like to start out with a question. And we're Talend developers. What's the best way for me to write a job in Talend? I don't care if you're experienced at Talend or brand new to Talend. I don't care if you're a senior programmer or a junior programmer. This is the right question to be asking. But it needs to be 3 things. If we all go back to our computer science 101 class, I don't know if they teach this anymore, but when I went to school it's got to be easy to read, easy to write, and easy to maintain. Very tough to balance those 3. You usually get 2, trading off the 3rd. So how do we do that? Well, let's ask some more questions. What if the job is going to change over time? That's the most likely scenario. That means you should prioritize those 3 to make sure that code is maintainable, which means it has to be somewhat readable, which means, yes, it's going to probably take a little bit more effort to write that code. Makes sense, right? If the job is a one-time deal, really one time only, and you can guarantee that, fine, knock it out. Write that thing as fast as you can. Get your result, get your job done. But I question whether that's really the case. Third is when you have a team of developers working together collaboratively, which Talend provides that environment. So I think you need to put a little bit more emphasis on the readability of your code. How many times have you gone back into your job or your code 6 months after you wrote it and pulled your hair out going, what the heck was I doing? Why did I do that? Well, if you made it readable, then at least when you got back into that code or when your fellow programmer gets into that code, they can figure out what's going on, right? Because it's readable. That's what we're trying to achieve here. To do that, you need to establish guidelines, software development lifecycle guidelines. This is very important. Now, I don't like the word standard. I prefer guidelines, and I'll talk about that on the next slide. But take a look here. These are what I call the foundational precepts. Read through that list. I'll give you a couple of, well, maybe a minute, 15 seconds. Tell me, anybody here in the audience, what's the most important precept to you? Just call it out. In the back. Anyone? Maintainability, okay. Optimization, okay. Any more? Performance? Functionality? Oh my God, these are all important. In fact, that's the point. They are all important. You have to keep all of them in mind. I tried to prioritize these. I couldn't do it. You try. I'm probably leaving off a few. But these precepts, basic precepts, give us that framework that we need to use when we write code. I don't care if it's Talend or anything else. Now, I have a favorite. Of course, I like to say compartmentalization because that's fun. But I think consistency is probably the #1 precept you have to adopt and adapt. Because that way, even if you do it wrong the same way every time, it's easy to fix. Okay? Moving on. And I am going to go through fast, so don't hesitate to interrupt. I'll encourage you to interrupt me, but let's keep going. So I just said I don't like standards. We don't call them standards because they're guidelines. We call them standards because they're rigid rules to follow. Now, I want standards when I'm building an airplane. I don't want that rivet to fall out and the wing to fall off in flight. But we're writing software. We have a little bit more leeway. So I prefer guidelines. Guidelines that talk to the way we want to write our code. And it's a collaborative effort. And it can be done in an agile way. So get together as a team, decide what your guidelines are going to be, document them, adapt them, and adopt them as a team. Do it in an agile way, and they can change over time. They don't have to be rigid. I like things that can bend and not break. And if standards are too rigid, you can only do it this way. When you didn't plan for something, how do you account for that? Right? You have to be able to account for the things that you don't know yet. So create that document along with some of the other useful documents. I'll call out the data dictionary because we'll talk about that tonight. A very important thing to have. We are doing data integration here, right? We need to know what our schemas look like. Document those in some way. And that's what gets us into job design patterns and best practices. What are they? Well, first thought I think most people think about is it's a template, a skeleton piece of code. And I guess in a way a job design pattern is just that. But it's really more than that because patterns are based around a use case. And there's lots of different use cases out there, which means there's bound to be lots of different patterns. So we need to dive a little deeper. And what we really want to do with Talend, because it's based on Java, it's a Java code generator, right? We have an object-oriented code language behind us. That means we should be compartmentalizing our code and creating units of work in an object-oriented way. It's about building a common reusable code base. Wherever you have a need for a particular thing that is repeated, make that job a little smarter, pass in a parameter, for example, and make that code a little bit smarter to handle the 20 different variances rather than writing 20 different versions of almost the same thing. Okay, you can do that with Talend, so you should. It really promotes reusability. Overall, the code base gets stronger. As a team, collectively, you now build yourself up a library or toolkit of reusable elements that will make the next project easier and can be done faster. Won't your boss like to hear that? It's about adopting that repeatable coding style to make it easy to read, easy to write, and easy to maintain, and that's really where best practices come in. Now, I will say that the rest of the night is going to be talking about best practices, and I really just glossed over on job design patterns, but wait, there's more. I wrote a new blog series. It's available to you. Just go to talend.com, look for me. It's called Successful Methodologies in Talend. It's a 2-part series, and it dives into physical job design patterns. I'm extending this series. Probably next time we come out to New York, we can do a session on the actual patterns themselves, okay? But read the blogs. There's some information out there. More to come. Let's dive into the best practices. Now, most of you, in fact, I think all of you missed the first session that we did. So I'm going to review a few of the best practices from the first 16. The first one I think everybody wants to understand is, how should I lay out my job on the canvas? Some programmers don't care. Well, you should. And when I was a new programmer in Talend, what did I do? I went to Google and I said, show me some examples. I want to see some examples. And what did I find? A lot of examples doing this left to right, drop down, left to right, zigzag pattern. And so I started using it. And after a while, I said, really? And then a little bit longer, I said, no, this isn't going to work. I can't maintain this code. Anytime I want to insert something here or here, I have to snip it, try and add it in, and I'm very fastidious with my layout. I relay out the whole thing. And that's wasted time. It's stupid. The code underneath barely changed, but it had to look pretty, right? So left to right, or what I call the zigzag pattern, is a bad layout practice. My conclusion. The next one I came across is what I call the snake, which just kind of goes everywhere. And I've seen some other ones or some interesting flavors of this. I even saw one that was what I'm now calling a reverse zigzag. It started from the bottom right and zigzagged up. That was different. But these patterns just don't work. This one isn't not just maintainable, it's not readable. It's hard to follow. What's going on here? So, top to bottom, left to right, this works. It's simple, it's plain, it has some rules, but it also is very flexible. Process generally would be top to bottom, hence the green arrows, the on, subjob, OK triggers. Data flow, left to right. And notice that not everything has to connect to everything. It's not a serial connection. It's a process flow with data flow embedded together. It's not ab initio, it's not Informatica, it's not SSIS, it's Talend generating Java code. So you can build your code this way, and we're going to talk more about this with some of the other best practices. Tell you what, this is what the microphone's good for. If you would, so everybody can hear.
How can I build that code, and what program would I use to build that format with the data workflow from left to right?
Okay, so Talend is the tool that you need to use. The Talend Studio is a Java code generator, and it comes with Eclipse editor, an IDE that lets you drag and drop components onto your code to connect to databases and process data and do all kinds of stuff. And it generates the Java. So I recommend before you leave is talk to one of our engineers, or we've got several Talend people. Talend people, raise your hand. Okay, so you can talk to 3 or 4 of them, and they can explain a little bit more the value of a tool like this. Okay? This works. I'm going to jump to number 5, which I really think should be number 1, which is how to handle exceptions. Hey, I said that right. I usually say how to handle errors. Well, it's not just errors. There's warnings and information, exceptions. And what you need to do here is create yourself a generic exception handler. Okay, it's about logging the errors and trapping those errors and programmably dealing with those errors, exceptions. And what I've done here is I'm showing a joblet, which is a unit of work that I've created in a job style format in our editor that you can include in your job flow. which makes it reusable. Okay? And I catch all the exceptions with the T-log catcher, and I've turned on the various exceptions that I want to catch. Any Java exception, any TDI or T-warn component exceptions. So programmatically, I can control what's going wrong, what to do about it, okay, with a generic exception handler. But it's more than that. You actually need a return code. Let's see if I can open this up without disturbing anything. Okay, it's just on my screen here. I'll move that over. Okay, so in help.talend.com, just type in return codes, and you'll find this article that I wrote. Now, I don't know, does this scroll up and down? Do you know? No, okay, so I'll have to use my mouse. And I have to be able to see. Okay, so the TDI and T-warn components are what we'll focus on, and these are available to you. You should use them sparingly but efficiently. The TDI, in fact, has 3 essential elements that you fill in. One is a message, the next is the exception code, and the third is the priority. Now, the priority is based on industry standards, trace, debug, warning, or info, warning, error, and fatal. Okay? Very standard industry priority level. So you select the level, but do you really want to use those defaults? That's what will show up in all your logs. No. You want to come up with a good message. You can concatenate a string of information together to log to that, and you want a return code. So let's look at how we might want to do that. Come on. Oh, now it's going too far. Great. So this is just an example. You can invent your own, right? But what I've done is I've created a digit broken into 3 parts. The first part is the priority, so it maps to the priority level. Info, warning, error, fatal, etc. The second digit indicates the system. Where did the exception occur? And the third is the type of exception. Let's look at an example. So you can see that the priority maps to the industry standards. The system then maps to the location of the exception. We have memory, storage, network, internet, database, big data, whatever it is. And then the type of exception, whether it was a permissions error, an open, a close, a read, a write, a check, a put, a get, whatever it is. And then you get these meaningful return codes. So 3605, 3 means it's info, 6 means it's file system, and 5 means it was open file. So now I know that I was able to successfully open my file, and I can, in my code, programmatically test for that value and decide how to proceed. On the other hand, if I got a 5701, 5, that's an error, a 7, that's the database, a 1, that's a permissions error, I got the wrong credentials. How many times has that happened in the last 10 seconds? Am I being hacked? This all gets logged to the AMC, Activity Monitoring Console database, so you can actually have third-party tools checking and having a pulse or a heartbeat checking for these return codes. Plus, programmatically, inside your code, you can test for these errors. So you can test, for example, for anything greater than 5,000, in this scenario, you know you have an error or a fatal condition to deal with. There's different ways to implement this. This is just something you put in your document. It's the easiest form, but then wherever you put in a TDI or T-warn, you put in the proper code. Some companies will, I'm sorry? The message, you can, I was just going to say, some customers will go so far as to build up a philosophy around this and embed it into a database, and then you would pull it out of the database. So you can construct useful messages. I would include, let's say, the file name and the path to that file and various other things. So this is just a simple example. Point being is that you want to have these 2 things in place. Now let's see, I got to pull this back. Where's my mouse? There it is. Woohoo. Okay? Now, last thing to say is and we'll talk about this a little bit more tonight. I should get to this. Every component in Talend is Log4j enabled since version 6. So there's really two types of logging going on here. Technical logging, which is based on a component, and operational logging, which is programmed in to your job flow, right? With things like tdie and twarn, tassert, and there's a few other kinds of ways to trigger an exception. But everything is going to be logged as a technical. This is when it started, this is when it stopped, this is the elapsed time, this is how many rows it processed. There's a whole variety of things, and we'll look into that a little bit tonight. Are you with me so far? I'm going to keep up the pace. Okay, tell me if I'm going too fast or too slow. Okay, you need naming conventions. In fact, gosh, if you should do this before you even start, right? File naming conventions, component naming conventions, directory naming conventions, file naming conventions. Everything should have a naming convention, and the sooner you adopt a naming convention, the better. Okay, so you tell me, well, I've already been writing code for a year and I don't have any naming convention, and every programmer decides to name their files their own which way they want. Well, that's not very manageable, is it? So you have two choices. Well, the first, you don't have a choice. Create a naming convention. The two choices are, from that point forward, do you just adopt the naming convention, or do you go back and apply that naming convention to previously written code? Wow, that's a tough choice. That takes a lot of work with little value. Just saying, right? But if you don't have a lot of code yet written, it might be worth it to you because it makes that code more maintainable. So you have to balance the cost of refactoring code just for a naming convention. It's a tough call. Personally, I think usually it's pick a date from this day forward, adopt this naming convention, and just be done with it, with the exception of reusable code modules. So you want to peel out those reusable code modules and apply that naming convention code going forward. All right. Another thing you have to consider is memory management. And in Talend, we don't need to expose you to all the alloc and dealloc and garbage collection capabilities of memory management because it's all happening under the hood. However, what you need to know is the way you write your job will impact your memory utilization. So you have to keep in mind how many millions of rows. I was talking to a customer today. I got a GC overhead exceeded. Why? Well, how many records are you reading in? 70 million. How much memory do you have? 8 gigabytes. I go, that's your problem. Okay, so know what it is you're doing. You know, don't try and read in enough data that requires probably 60 gigabytes into 8. It's not going to happen. Okay, you also need to consider T-maps. How many lookups in your T-map? In fact, this case was, the basic data was processing was only 70,000 rows. The lookup, however, was 70 million. So you need to think about these things. Also, where the job was being executed only had 16 gigabytes of memory. His studio only had 8. He couldn't run it in his studio or the job server. Now we do have a nice little feature down here called Memory Run for the developer, and you can execute your job locally or remotely through that tab, and it'll tell you how much memory you need. And it'll tell you when you've exceeded it. There are other reasons, though, why you might get memory errors. For example, a customer would have a table layout with 700, maybe 800 columns. We run into that a lot when we're dealing with COBOL copybooks and old mainframe-style systems. That could be a problem. And now it's nothing that you can do in Talend. It is a Java limitation. Java can only have so much in its stack. And once you've exceeded that, you're done. But the trick is to break it down into smaller pieces, right? And you can do that with Talend. So you use Talend to leverage the limitations, okay, constraints of Java. Okay? So there's lots of things to consider. You also need to consider whether or not you're running parallelization or other things like that. So one thing you can do on each job on the Run tab, you can specify the parameters for the Java virtual machine, a minimum and a maximum. But be careful there too. We had another customer who said, well, gee, I've calculated with my 3,000 jobs, I need 90 servers to run them. And we scratched our head, at like $3,000 a month per server. That was a big, expensive prospect. Well, okay. We took a look here. They had set their minimum required memory to 1 gigabyte for every job. And that's what they calculated it on. But most jobs don't need that much memory. All you have to do is lower that to, well, the default's at 256 megabytes. Sometimes I'll lower it to 128. That's just a starting point. The key is the max memory you set it to. If you set it to 16 gigs and it only needs 4, fine, it's only going to use 4. That's okay. Plus you can override these values in our administration center, our management console, the TAC, Talend Administration Console. Yeah?
How would you know when, how much gigabytes of memory that you need for a certain job?
That's what the memory run tab will do. So you can run the job and it'll give you a graphical representation of how much memory is being used in your job. It's very nice. That was a new feature early last year, I think. So it's been around a little while. Okay, we're going to do a sidetrack here because we are dealing with data, and I'm a database guy. I've been doing databases for my whole career, 36 years now. So while we have a software development life cycle, I've introduced this notion that the database needs one too. So I'm going to share a little bit of that with you. Question: doesn't a database need best practices too? Of course it does. It changes over time, right? So we want to make sure we have a way of managing the schemas in our system. So we're talking about schematic lineage. And there's a whole bunch of metadata management tools out there and stuff, and I'm not going to get into that tonight, but the life cycle is important. So let's look at that. I think adopting a development database lifecycle is key. And frankly, it's easy because a database only has to go through 3 stages of life. A fresh installation of the current version. You can spin up a whole new, brand new system, boom, for QA, for example. A version that you can move from one to the next. That's a apply and upgrade. And then a migration, which is really an upgrade on steroids. So an upgrade can involve things like adding a table, dropping a column, truncating a value perhaps, maybe changing some constraints, maybe. Where a migration is, now you're going from Oracle to Microsoft, and you're splitting 2 tables into 3, and you're doing all kinds of serious transformations that require rules and management of those rules. So other than that, that's all you really have to do in the database lifecycle. Now, of course, you do all that with metadata management in terms of tracking the lineage, but it boils down to being able to drop, create, alter your objects. So one thing I do is I assign I like to script my databases. That's just me. I will write the SQL script to create a particular object, whether it's a table or a view or a stored procedure. Okay? And everything in that script knows everything about that table, right? So it knows how to go from version 1 to version 2. Right? And I use some switches and some techniques depending on the host database that I use. But this idea that you can have script upon script upon script that does everything within the script to apply the change, create tables, alter tables, all these different things within one script, it's very, very hard to manage. Okay? How do you know what the current version is? I had that example. It's a long-winded one, so I'll have to skirt that one off to the side. But if you want to ask me that one later, I saved a company, I think, about $30 million when I applied this to their database madness that they were going to do. They were actually going to modify their application code to track the old version and the new version because it was going to take them 3 weeks to migrate it. I got it done overnight just by doing this. You should have a good ERD, of course, and I call them SQL object creation scripts. Okay? Single table, single script. You can manage that, put it in your source code control system, and put it in your metadata management, and everything's good. Next part of this, though, is the modeling itself. Okay? Now, I'm going to date myself here, but I hope to date a few others in the room. Who remembers what a hierarchical database model is? 2, 3 of us? Okay, 3 of us. Who remembers what a network model is? Same 3. 4 of us. Okay. Who knows what a third normal form relational model? There we go. Everybody raises your hand. Thank you very much. And of course, star schemas, snowflake schemas, and I'm not talking about the snowflake product. And then of course, Data Vault. These are all modeling methodologies available today. We primarily do the third normal form. Okay. Well, same thing, right?
No, but I mean, not like big data.
Correct. Big data is not a relational database. So what we're talking about with big data are flat files. That's a different conversation. Yes, indeed. But there are techniques for putting structure on data files in Hive on a Hadoop platform. And some of us know I prefer Data Vault for that. It's designed for that. I want to focus more on the process of data modeling. This process, I think, really reflects the steps we go through in the life cycle of the database. We understand the data. We got to start there. We then model it. We validate that model. We go through those iterative loops until we're really ready to build it. Of course, that means diagramming and talking to stakeholders and doing all that good stuff. And once we build it, we deploy it, and then we test it. You don't want to release a database that isn't tested. And I can tell you, I've worked on many projects where programmers are building databases and they've never done one before. And they don't follow a process and they create tables because they think they need them. Well, they do need them, but they don't have any concept of how they relate to other data in the company. And that's why big enterprise companies wind up with 300 different databases to track a customer. Really not a very efficient way to go about things. So there's a blog series. I'm going to promote my blogs tonight, I guess. It's a 2-part blog series that talks about this, best practices around data modeling. In fact, you might be interested to know I collapsed the 50-year history from hierarchical, actually flat files to Data Vault in 2 paragraphs. Lots of links, so go read that one. It's really interesting. I had to do some research to actually refresh myself on some of that.
This is agnostic of the database provider, like whether
Yes.
it's a columnar provider versus a...
It is. It's completely agnostic. There's more discussion I could have around the various different types of data stores. I have a webinar on the Agile Data Lake that I talk about that, right? Hadoop, NoSQL, relational, both row and columnar, and of course the big data techniques. So when it comes to data modeling, you're probably all very familiar with the logical and the physical layers. Who wants to tell me what the logical layer is? The business friendly. Really? Entities and attributes? Will your accountant understand what you're talking about? No, you're right. So it's not business friendly. It's programmer friendly, but it's not business friendly. What about the physical layer? Who wants to tell me what that is? Come on, from the back.
That includes the physical storage and things like that.
The tables, the indexes, the columns, the keys, all the physical features stored on disk. How's the data stored on disk? All right, well, so what I've done, and I've debated this with many people, I separate out the conceptual layer from the logical layer, because this is the layer you can talk to the business with. If you use an information model rather than a data model. So that's where the information architect comes in. This is where you talk about people, places, and things rather than entities and attributes. Okay? So the conceptual layer, I find, is the best layer to talk to the business with, because everybody can understand that, and then you transfer it into the logical layer and then into the physical layer. But what do we do when the enterprise has 300 different databases that contain customer information? I throw on another layer I call the holistic layer, which is just a way of corralling data silos. Data silos proliferate around the enterprise in a huge way for big companies. So you need a way to even get to a conceptual model, and that is to identify and find where all the data silos are and how they relate. Not how they relate, but where they relate. So let me restate that, where they relate. You define the how in the conceptual layer, but where is everything? That's what the holistic layer is all about. And my blog series on this will talk about all of those details. I just wanted to introduce it to you tonight. Any thoughts on this? Holistic layer is new. Relatively.
A lot of times, the application group doesn't want to go through this ER relationship process. You get a call, you want a table, you can have it in 3 hours. You say, well, we don't need that table. They don't want to hear that.
Did everybody hear his question? When a developer needs a table in 3 hours, how can you go through all this process, right? You don't. You don't. In fact, whoever said that database design and modeling was agile? It's not. It never has been, and it never will, unless you're using the proper data model. And there is a way to do that. So watch my Agile Data Lake webinar, and I talk about that, because there is a way to be able to do that, as long as you have an agile modeling capability. None of the ones that you're used to do, so you can't. And if they're just going to throw out a table, tell them, great, here's your table, but it has not been managed, and it might go away tomorrow. No, it has to be part of the whole ecosystem, which is if you've got this process in place, and at the very least, you want to have this, depending on the size and shape of your company, you're going to want that. Okay, I want to keep moving forward. So here's the progression, and that's what a holistic model might look like. I did that one for a big enterprise customer, a retail company. I then transformed parts of it into a conceptual model. I used UML for that. And then from that, I was able to create a small, I started big and I kept drilling down to just the physical model for what I needed now. But because I did the holistic, anytime somebody asked me to add a table, I should have already identified it. It should have already been in my holistic and my conceptual model. Now it's much easier and faster to add. So that maybe is another way of addressing that kind of question. Was there somebody over there wanted to?
Is the holistic model like an ontology?
I love that question. No, it's not, but it incorporates ontologies. Now you see this bubble in the center that has a second ring? That's an ontology. So I've identified where ontologies go because I need to be able to know how to search for information, right? So in the holistic model, if you've identified where the ontologies go, in fact, here's another one down here, okay? I don't define the ontology, but I define the fact that, hey, there's one over here I need to deal with, okay? And then I would encapsulate it in here, in the conceptual model. And of course, how you implement an ontology, you're not going to really need a logical model, right? Now we're talking about something else completely. Okay. My favorite Columbo. One more thing. Just one more. I'm going to annoy you one more time. Create a data dictionary, right? At least have some rudimentary data dictionary. And I'm going to offer you two options. One is if you're creating Talend jobs, and you look at the bottom left corner of your project repository, you will see the tab called Documentation. And in that documentation, you can generate a full wiki site of your project. Now, if you've done the right thing by making it readable, by putting in labels and comments and readable things everywhere, then you're going to generate a data dictionary effectively. It's not a very good one, but it's a wiki on the whole project. Or you can use our product, Talend Metadata Management, which allows you to encapsulate the glossary. And our new product, is it what we call it, glossary or dictionary? Data catalog, excuse me. The new data catalog that's coming out will allow you to define all this stuff and store it and manage it, and that's really what you need. You've got to have a data dictionary, and the data catalog is the product that we're coming out with. I'm not going to go into the sales side of that. That's not me. Jonathan, if you want to ask about data catalog, you can go talk to one of our guys over there. Okay. Well, it's only 3:45. Oh, wait, I'm in New York. That's right. Let's move on. Best practices. I'm going to pick up from where I left off last time. Sorry if you missed it. Number 17, code routines. Talend is an extensible product. It's generating Java code. And sometimes even the components that we give you, and there's over 1,000 of them, isn't enough. In fact, sometimes the components that you can pull in from third parties isn't enough. Sometimes what you really need to do is add a Java method to help the idea of writing reusable code. What if you're parsing a string? Maybe that string is a long, complex XML string and you want to replace all your slashes to double slashes because of some use case or need that you have. So you can write a function or a method in Java and save it as a code routine. So in the project repository, under the code section, there's a folder called routines, and there's a folder called system. So we actually deliver to you, the Talend customer, system routines. In fact, you're probably already using some. Has anyone ever used get current date? Okay? Yes, yes, yes. That is a routine that we ship with the product. It extends Talend. There's no component for that. Doesn't make sense. How about a sequence generator or an is-null validation? Now, I had a case where this sequence method wasn't good enough because it was integer-based. I needed a big int. So I copied the integer code over and I changed the data type and made it sequence L and changed the data type from short to long. Okay? Now, what you do is you add that code to a file inside your code routines, and there's a section here at the top that is the comment section that you should adopt a guideline on how you want that scripted, because this will show up as your helper text to your programmer. When he's trying to pick the right method in the little pop-up window, the helper pop-up, it'll tell you what the purpose of the method is, what the parameters are, their data types, and an example of how to use the method. This is just good programmer citizenship, right? Create the routine and add some value so that you'll even know, what did I write that method for? What does it do? You can get that by simply including the comment in the section. Other than that, you can write whatever Java method you want. Yeah?
If I was building my own routine, how do I differentiate, or maybe by naming convention, from what Talend provided, so that if there's an update and what I build came along later, I
Okay, so naming conventions are important. What do I do if I wrote a method that Talend uses that name? So within a project, all these routine names need to be unique. So come up with a naming convention of your own and be sure to check it when you test after an upgrade, if you have code routines. Yep. Just to make sure we didn't introduce a new one that happens to borrow your name. Number 18, repository schema. So within that project repository section, we have all kinds of capabilities. And here's the expanded metadata section. So over here on this panel in the repository, you've got your job designs, your joblets, your database connections. In fact, here are your database connections under metadata. But we have all these other types of metadata that you can create becoming reusable objects. When you put them here in the project repository, that means they're reusable in any job within the project. So you define them once. When they change, you change them once. Any object placed in any job will automatically inherit the change. That's what object-oriented programming is supposed to be all about, right? Well, this is project management of your reusable objects. Now, there's one in particular I want to call out. It's called the generic schema. Starting with, let's say, a connection to a database, I have an account table with 12 columns. Great, I can use that as an object. I can reference accounts as an object in my code. And boom, I inherit the 12 columns. But I'm adding value. I want to add 4 more columns. But I don't want to go change my table. I'm joining it with another table, and I'm adding 4 more columns. So I need a generic schema that has an object name, MD underscore account data, which has those 12 plus 4 more columns. So as I read the data in for 12, I join it with the other 4, I output 16. I need a schema. Now the lazy programmer will just go into the job and add the 4 columns built into the code. But every place you need that, you have to change it. If instead you create a generic schema and promote it to the project repository, you can reuse it everywhere, and anytime it changes, it only has to change here. and then all your other jobs will inherit the change, even if you've used it multiple times within the same job. Okay? So within the repository schema, I encourage you, strongly encourage you, to use the metadata section. A lot of times I'll open up customer jobs and I don't see anything here. And that means you're not getting the power and the value of that capability. Now, we talked earlier about logging, so the next few slides are about logging. As I mentioned, since version 6, we've enabled all components to be log4j enabled. Okay, and by default, they're turned on. Now that means in the project settings section, you'll find a piece called log4j. If you open that up, this is what you'll see. Now, I'm not a log4j appender expert, but we expose the appenders, the XML framework for enabling how and what gets logged into the log4j output. Okay? Notice very carefully that some of them are enabled and some of them are not. The console is enabled because it's not commented out, yet the log stash is commented out. So you have to go in there and enable it by uncommenting it. Now that appender goes live. And there's a whole bunch of different appenders that you want to turn on. I'd say console and log stash are the key appenders you want turned on, because you can control the level of which you capture, and we'll look at that in a minute. But what does this mean? That means you have the full ELK stack at your disposal. Logstash, Elasticsearch, and the Kibana UI, a common framework for looking and monitoring your technical logs for the execution of your jobs. So this is on the studio side. On our server side, the TAC, what you do, you enable each task. So you write a job. The job performs some function. And you go into the TAC and you want to run that job. What do? You go into the job conductor and you create a task, which is a wrapper around that job, applying parameters or conditions under which you want to run that job. Where is it going to run? How much memory is it going to run? And guess what? What level of our log4j you want to run. So if you set that to info, you better be in your development environment and not production. You really don't need info or warning in production because it's going to generate tons of information. If you haven't already figured that out by the time you roll out into production, then you're not doing a full process in your life cycle. Set your production probably to error or fatal, depending on how fast you want it to run, because there's overhead in logging this data. Make sense? Okay, so this task is the wrapper around the job, and you have all these different settings, including the log4j level. Okay? Any questions about that? It's really easy once you know what to do. Oh, one more best practice. When you install the Logstash server, make sure it's on its own Tomcat. You don't want to share the Logstash server with the same concat of your other web apps, because it's going to be a pretty heavy I/O. It will drag down your other web apps, like the TAC, or like the next one, the AMC, the Activity Monitoring Console. Now here's your operational logs. Remember we talked about the exception handler, the generic log processor that I showed you, the joblet, with captures all the Java exceptions, TDI and TWARN exceptions. What we want to do here is choose how we want to output that data. And we have lots of choices. So we have in the project settings, under job settings, stats and logs, the ability for you to capture statistics, logs, and volumetrics. We've been talking about logs so far. You can also get statistics. You can also get chronometer types of readings if your use case warrants it. You can display it on the console, write it to files, or write it to a database. If you're writing it to a database, you give it the connection string of where that database is. In that database are 3 tables: the log catcher, the stat catcher, and the flow meter catcher. We give you the scripts to create the tables. You put it into a database. I don't care if it's Oracle, MySQL, whatever. But you can then catch all of those exceptions in the logs of the database. A much more efficient way to do monitoring, administration, operations around and surrounding these programmatic logging techniques. Yes?
So, logging for AMC, is it just enabled for the jobs that are done on TAC,
The AMC is enabled at the project level. How you use it is determined by the task that you create and the number of T-die and T-warn components you put in your job. If you don't put any T-die or T-warn jobs and your job runs without an exception, you will never see anything logged to the AMC.
Yeah, but anything that's run on the studio, stats for the studio are also captured on the AMC, right?
Yes, because I turned on console and database, right? You have options. You can turn them all on or just the ones you want. Now on the server side, you have a visualization tool. In fact, you can access this with the AMC perspective in the studio as well. And take a look down here. Here I picked a particular job or task and I've selected my messages and my return codes. So there we can see I've got a return code of 3708 and a message that says database, 20,000 source users generated. That's the kind of message I construct. You know, informational, purpose-based messaging with a return code. It's right there in the AMC. That means I can write queries against the database externally. I can get statistics and analytics out of my jobs beyond what's just being shown up here in the visualization tool, which shows me where most of the time was spent. And that job was 92%. Then the log processing joblet had 5 occurrences at 2% each. Tells me something about the job. Okay, any questions about this?
Will it also tell how much memory is it consuming by any chance?
No, but I think the log4j will. Yeah, that's more of a technical thing, yeah. Okay, moving on. Number 21. How many times have you written a very complex process that had 10 steps and you ran the job and it took 2 days and that was your optimal performance and on step 9 it failed? Dang, what do? Do you start over at the beginning and waste another 10 or 2 days? Or is it possible to pick up where it left off and finish the last step? Recovery checkpoints is a technique that you can implement that's fairly easy and straightforward. What you do in your job design, and you can see my job there, there's a red bubble around on subjob OK. Remember, that's a trigger that connects 2 components. If I right-click that and I go down to the error recovery tab, I can give that a name. Just by virtue of giving it a name, I've created a checkpoint. And it will generate the proper Java code to save that checkpoint whenever it hits that trigger. You give it a description for the DevOps person to know that when or if this checkpoint failed, what instructions are necessary to manually correct the situation so that he can continue with the last step. For example, maybe he has to truncate a table or delete a file or rename something. There might be some quick manual intervention that can occur that would allow for this next step to continue. And if there are no manual interventions, then at least tell him you can just go, or tell her, right? Now this is on the developer side. That's all you have to do. On the TAC side, when you execute the job, you have the job server that is executing this task, and it has several conditions. And it's set over there on the right when you create the task. There's a drop down that lets you specify wait, reset, restart, or recover. Now in our case, we're talking about the recover. That means you executed the job or the task knowing that there are recovery checkpoints built in, so that if any of them failed, manual intervention or even automated intervention can occur. That's what the reset, restart, and recover task is. Let's say you're running this task and the job server went down. As soon as it comes back up, if you had it set to wait, it'll pick up where it was and keep going. If you have checkpoints, it will know the last good checkpoint and it will continue. Now that's what you want when there is no manual intervention required. But if you know as the programmer that in order for this to continue, I have to go delete that file, then set it to recover task. The DevOps person will open up the recovery management, see the error and the instructions that you gave them, follow the instructions, and then kick off the job from the last step, and it'll complete task 10. Okay, so all that was really required is a little thought into the process. You know, understand what it is you're asking of the task, the job, the DevOps person to do. Does that make sense? Yeah.
When the process state is, does that already processed data, does it get stored in some cache or something?
That's something you have to determine as a programmer. Okay, so if you're setting a checkpoint, you have to understand that it's effectively stateless, which means that anything that has pre-executed has to be complete. And the next step needs to be able to continue as if it was starting from scratch, because all the other steps, so you need to decouple the steps. So if you have data in flight, then it can't pick up from that because the memory's gone, right? Nothing in memory, unless you write it out to disk, you can do that. So it's all about how you employ and develop the stages of your recoveries, your checkpoints that you decide how to adapt a stateless or stateful operation. There's a whole other conversation around that too. Yes?
How does this translate to run a job in the cloud? You're in the cloud, you create a workflow and
That's a big question. It depends on a lot of different moving parts. And rather than go into that right now, we'll take that one offline. There is an answer to that question. It's a great question. How do you deal with this in the cloud? Depends on how you're deploying in the cloud and what you're doing. Okay. Was there another question? Yes. If you don't have the Talend Studio, you can't do this. You don't have the Talend? Then you... Oh, you don't have the TAC? Then you can't do this. If you just have TOS, that's a single user version, free version of the software, you can't do any of this. These are features that you get when you buy the product. If you don't have the TAC, you can't use checkpoints. You won't, if you don't have the subscription-based product, that feature is not enabled. Okay, so for those of you using, okay, show of hands, who's using TOS? Talend Open Studio, the free version, yeah, okay, there's always a few. And I welcome you coming and learning, because then you're seeing features you're not getting. Okay? I'm not going to try and sell you, but you can get the idea. Tell them harder. All right. And you can tell them you came tonight and you say, wow, look at all these best practices Dale showed me. We can't do any of them. Well, you can do some. Okay, joblets, great. You can't do those. Joblets, you saw the one example that I showed you of the the log processor, the exception handler. That is an unusual joblet, frankly. It has a log catcher in it, which is a listener, which executes first. And it's embedded in the code, so it gets shared across the code, the job, and any job can have it. Great. That's a foundational building block. But most joblets are really processing data. They have an input and an output so that you can embed the flow of your data through a joblet. And the joblet can do some very specific unit of work. In my case, I'm passing some data in, I've set up some values, and I'm updating my control record. And I'm letting the data pass through, but I've updated a record. I need to use this as a utility job, or joblet, several places in my other jobs. I only have to write it once. Okay, and I've handled for an error condition, and I've got an input and an output. That's what a real joblet typically does. Now here, this is cool. This example is handling data structures. You can also have input for a trigger and output for a trigger, which means you can say on subjob OK, invoke this joblet and let it do something and spit out data. So you can mix and match whether you're using trigger-based or data-based input or outputs. So joblets become very flexible and key structures within your project. Okay? And I'll be honest with you, you don't come across very many use cases for using them. So when you do, it's a gem. And you want to build it, and you want to make it work right, and be smart about it. Because joblets are very powerful things. Okay? In the first section, we talked about joblets versus T-run job, which is calling another job from a job. Both promote reusability. The T-run job is the most frequently used way of orchestrating execution of data flows across multiple jobs. Joblets are embedded in your job, very reusable things, but they are not meant to be jobs themselves. I saw one job that all it did was call a joblet, and the joblet did everything else. That's not the idea. All right, number 23. We're cranking through. I guess we got time. We're all right, right? It's only 10 after 4. That's what my watch says. A new feature that we added in 6.2 was the ability to create test cases. Now, some people say, well, isn't that a unit test? And no, not really, because a unit test is meant to test a unit or a module. What this is the ability to create a test wrapper around a component. And not all components, but many of the components within Talend. If you right-click on it, I'll right-click on this as a tJavaFlex component, you'll see in the menu a Create Test Case menu item. Click it, and it will generate another job. That job is a test job around that component. So it actually pulls the component down and builds a wrapper or a harness flow around it. We'll see that in a minute. So you can create these jobs that are really test cases, and they become their own independent executable jar file, which you can then build in as part of your unit testing process flow that you can automate through tools like Jenkins. Okay? It's a whole nother conversation about CI/CD we could have. That's for another day, but this can factor into that because you're designing and building component test cases. Now in my case, what I'm doing here is I'm creating this test case wrapper around the component, and it has basic flow. Okay? Let it paint, here we go. So here's the test case. Notice in the middle, there is my component that I created the test case around. And it essentially has an input and an output. It has a green box around it, which means you should not touch that. In fact, if you change the component in the job, it will automatically inherit the change in the test case. If you change it in your test case, it breaks the connection, and you lose that capability. Not a good idea. So anything else, however, around those three components, you can do whatever you want. The idea is to produce a pass or fail. So we give you the ability to read in a data file, some sample input file, and you can have it be good data, bad data, really bad data. You can have it small, big, large if you're doing some performance testing. You input that data, you process it through your component, and you write out the results, either to a file or a database. Then you compare the results with a predetermined result file. So you're creating two files. You're creating an input file, and you're creating an expected results. This is QA stuff, right? You can use the same test case and pass through different input files and have different result files. So you can reuse the test case for all the different combinations that you might want, all resulting in a very simple pass or fail. And then when you automate the process, you can either test by number of errors or percentage of errors. So that's a Jenkins thing, right? You can test for how, what your level of pain or threshold of pain is. Excuse me. Has anybody tried creating a test case in Talend before? One back here. Anybody want to now that you know that it's available? 2 or 3 more. Don't create a test case on everything. Go for the meat and expand from there. Decide in your developer guidelines what your best practice is. Number 24, and we're going to 32, right? So I got to keep going. There's a common need when you're processing data, result sets, to be able to iterate through row by row. Pretty simple. Now, some components allow you to trigger with an iterate, trigger itself. So I'm reading a Postgres table, and I'm saying row by row, pass it into the next component. Now, in my case here, the next component is iterate to flow, which is a special component that allows the Java being generated under the hood to process that one flow and pass it on to the next component as a data flow. Because TMAP doesn't let you link up and iterate trigger. So you need to take the data, let's say it's 100 rows, you process it through row by row, one row is fed to the TMAP. But you need the iterate to flow component in order to naturalize the Java code underneath to process it properly so the TMAP can actually accept that record. Downstream, you may want to parse that record up and list through or process through some of the elements of that record and iterate again downstream. You can do that. Where you choose to use your iterate to flow or flow to iterate components, you have a lot of flexibility. And if you think about the value here, I've seen a lot of programmers try and design these very crazy jobs because of this limitation. And I don't even think of it as a limitation, but this construct will allow you to simplify a lot of code because you can pass things in record by record and iterate through them, rather than try and build loops and do all kinds of other crazy things. Very powerful components, but you usually use them in tandem. Iterate to flow and flow to iterate. Okay? Any questions on that one? A use case. I am reading some records out of here, and because I don't want to do anything until I've processed a row, I might want to iterate through them. This example doesn't show that. Yeah, if you want to go all the way to the end with one record, see what will happen here is if I have 100 rows, I'm not going to come back to row 2 until row 1 is completely gone through the entire thing. Otherwise, the data will come through as a full flow. It's about the pipe. How much data do you want coming through the pipe? One record or all your records? So there's thousands of use cases where you might need to iterate through. But that's essentially the parameter. Do you want to process that one row end to end before reading the next row or not? Okay, this is one of my favorites, the TMAP. By far, the #1 component used in Talend is TMAP. In fact, I don't have the numbers yet, but Mark Balcanati will get them to me. I've asked. He's not here tonight. TMAP is used more than all the other components combined. It's a very useful thing. But a lot of us just use the defaults. How many love default values? How many of you guys have SQL Server, Microsoft SQL Server? Okay, when you install SQL Server, does your DBA change the password on SA? No? I'm going to talk to your DBA. Yes?
Is T-Java not a post-use component?
Say it again?
Is T-Java?
T-Java is a very widely used component. It's up there, top 5. T-Java, yeah. Why not? That's a common one. I use it a lot too. Yeah. Okay, so TMAP. Essentially what you're doing with TMAP is you're reading data and you're putting it into the TMAP. That's your input. And you are potentially using that TMAP to do a lookup or multiple lookups. So how does it work? Typically, the lookup will be executed first. I don't know if you've ever watched, but it will go read your lookup and load it into memory, and then it'll process your data and do your transformation that you've defined inside your TMAP. Well, that's fine, except for when you have 70 million rows and you don't have enough memory. What do? Well, you focus on the lookup model, okay? And let's take a look at that. So inside common lookup, we've got row 1 coming in. We're looking up row 2. We have a load once is the default lookup model, which means load the lookup values into memory and then do the joins. Very fast, very efficient, great. And you can do whatever other transformations. I'm setting the key to show how to do the join. It's transforming into a SQL, even though it could be flat files, right? But this may not be the right lookup model for you. What do you do when you have to deal with the memory constraint? Well, I'm going faster than my slides tonight. There are 3 options for the lookup model. The default, which is load once, and that works in a lot of cases. Or you can use the reload at each row. Who's used the reload at each row? Anybody? We got one back here. Almost. No? No? Okay. So the reload at each row means that when you're processing your data coming in, you're going to do your lookup row by row. So it doesn't read it in first and load it into memory. No, as you're processing the data, it goes and it looks it up, row by row. Okay, what's the trade-off? Performance. Yes, so the trade-off is memory versus performance. If you don't have enough memory, you sacrifice performance. But there's some other considerations. Let's say your lookup is 200 million rows, and you're processing 10 million. Okay, of those 200 million, how many will really be used? Let's say 5 million, because some of the rows will share the same lookup. So you can cache it into memory. So the first time it reads it, it loads it by doing the lookup, read from your table, have good database design practices there, and then it'll cache it so that if it needs it again, it won't look it up again because it'll find it in memory. But of course your memory footprint will grow. So you have to be very conscious of what you're asking it to do. Now there's a trick to making this work, and this I have to explain. When you select the reload at each row, you must create a key, which is a global variable. You do that by opening up the global map key. You press that little green plus button, and you can create your global variables, which represents the key for your join in your SQL query to do the lookup. That's simply all we're doing. So I've got my connector joining the 2 tables, and I've defined 2 values as my key. There's a hub account and a hub user key. That's all I have to do inside the TMAP. But on the lookup SQL query, I can no longer just say select star from table. I have to now say select values from table where, you have to add a where clause, the key value of the table matches the variable value I've just read in from the row that I'm processing. Row by row by row. So for each row, it's saving the value of the keys into your global variable, and then we're using this method, this code routine, called system get, where is it? Global map.get. So it reads off the heap, goes and retrieves the current value, it puts it into your constructed, dynamically constructed SQL query, and it pulls the row. Done. In fact, this global map.get method is a very useful method. When you really start using this thing, you'll love it, because it lets you do all kinds of things in lots of places. Okay, but it's required to do a row by row lookup. Okay, we're getting short on time, so I may not get to all 32. I apologize. But so far so good? Okay. I'm good? I got 10 minutes though, right? I just got a signal. We have until 8? Kyle, you said 10 minutes. I got 40. I can slow down, catch my breath? You tell me. We're good till 8, but I need to finish like 10 minutes. You guys want some networking time, right? So if I finish it like quarter till, is that good? I think I can squeeze most of them in by then. The pace is okay?
Can we have access to the deck?
Absolutely. More than happy to get that to you. Yes. Okay. Oh, sorry. Okay.
What I tried was like doing a disk swap. Will that be a better option than going to reload? Because the reload for each row is limited only
Yeah.
for the SQL database.
So the question is, what about the disk swap? would that be an option? It is an option, but here's your performance stack. In memory is fastest, row by row is next, disk swap is the slowest. Because you're writing it out to disk. You've got disk I/O involved. So absolutely.
That I can use the row by row
I'm saying again, what about the row by row?
for the flat files. Like I have
Yeah, you can. Any one of these components that feed the TMAP can be a flat file.
yeah, but the third point is this method is limited to SQL database.
This is an SQL database lookup, yes, for the lookup.
But I have 2 files.
2 files. So yeah, there's some ways and techniques to do that, to turn it in, to make it look like it's actual SQL, to make it work. But if you're going to be reading flat files of how many millions?
50 million and
50 million and 5 million.
the main is 5 million
Yeah.
and the lookup is 50 million.
Okay. So why isn't that in a database? Are you talking big data? Okay, that's a different conversation. Okay, so, and we want to talk about Spark and,
The DI job, like no, it's not the big data.
okay,
We have it in a different server, but it is not in HDFS. It's a flat file.
right. Well, don't expect flat files to behave like relational tables, relational databases, first and foremost. So your flat files are going to process as fast as your disk I/O can read them. You might employ some parallelization techniques to speed it up and process that file in chunks, right? So there are techniques around improving performance. This load once isn't the technique that you need, okay?
So is there any way I can read? Is it there in your blog or is there any
Not on that specific technique, no, but we can certainly talk about it. Yeah. Okay. Global variables. Global variables are effectively context sensitive, right? I guess that's why we call them context variables, right? You can create variables within your job. You can create global variables within your job. That's interesting. You can also create variables within context groups in the project repository, which are global variables. We also have a bunch of variables that are global variables. So what the heck are we talking about? They're all just variables in memory. Everything's global, essentially. It's how you use them and where you use them. So one thing you can do is you can use a component called setGlobalVar, which will create a variable in memory at runtime. That's its purpose. I want a global variable, and I don't know what it is until runtime. So boom, you create it in your code with a component. Now there is a corresponding tsetGlobalVar, which is the same thing in big data. So you can create those kinds of things in big data too. So that is something. And guess what? You can use that same function, globalmap.get, to retrieve the value in that global variable. It's basically saying to your job, I want to allocate a global variable dynamically. Or you can use the global var. Oh, that's the one for big data. I'm sorry. I'm one slide ahead of myself. That's a MapReduce job. Again, it uses the same global map.get function. Okay? Now what I'm doing is I'm using it within an expression within a TMAP. So that's a global variable and how you access it. Here's where thought I was going next. There's also a slew of system global variables. Every component returns some set of values. Some are common, some are unique. And if you look at a job, and I'm pointing to this first one is the tDie component. You can find its object name, tDie_2, and it has these 4 system global variables available. Typically, they're only available after the component has completed execution. There's a few exceptions to that, but most of these global variables have to be set before they can be read. So error message, die error message, die error code, die priority. Gee, doesn't that tie into the error handling that we talked about? Yeah. Then there's another one I have, which is a tlog row. It only has error message and number of lines. So I can retrieve the number of rows it processed after it finishes processing. A lot of the database components will tell you how many records were inserted, how many were updated, how many were deleted. So you don't have to create your own variables and counter mechanisms for retrieving number of records processed. Okay, remember my error message that said so many 20,000 records were generated? Guess what? I retrieved it from a global system variable on that component that did the insert into the MySQL database table. Okay? There's a whole bunch of these types of global messages. There they are. The ones that, even the number of lines rejected, or rows. We call them lines because it could be a file, it could be a database, whatever. And then there's two more that just nobody seems to know about. They're called global.projectName and global.jobName. And somebody please tell me where those are going to be useful. In logging. Thank you. Absolutely. I even like at the top of my job to write out what my project name and job name is to my log, so that when I'm looking at my log, I know exactly what job it entered, right? Especially when I'm orchestrating a string of multiple jobs, calling jobs, calling jobs. Very useful to logging. Maybe you can use it for other things. And what was your? Statistics, yes. Okay. Now we just mentioned context variables, and this is the place in the project repository where you can create a whole bunch of organized global variables. And by putting it in context, that means you're setting up a suite of default values depending on the context group that you define. Typically, the context group is defined aligned with your environment, dev, test, prod. So when you execute the task, you tell it what context you want to run it in. I want to run this task in dev. Very useful thing is on a database connection, right? Your database in dev better be a different database than prod, and yet do you have to go in and modify the code to switch it? No, you don't. You create a context group based on the database connection variables, set it to dev, to test, to prod, set the proper default values. But wait a minute, isn't that exposing username and passwords in my production environment? Well, yes, unless you externalize it and you save those values off into a file or even a database and load them at runtime. See, when you create the context variables, you're instantiating them within your job. The default values of the global context group can be blank, or you can override them in the TAC, or you can override them at runtime by loading them in from an external mechanism, typically a file that's encrypted. Things like that. So you use the context load component to do that. Passwords will be encrypted in that file. Has anybody used this? A few of you? An external file is clear text except for the password. It'll be encrypted. Yeah, yeah, and you can create them using the context dump component. So you can create them by hand, or you can write a little job to create them. And some customers will actually put all of that data into a database and write a joblet to go read them in the pre-job section of the code. So you can set those values at runtime. We might even make it. Where did Laura go? Okay. How many times I've been asked this question, I can't tell you, but I have 300 jobs. Do I have to write 300 tables? Do I have to write 300 jobs? Really? Can't I just write one job? It's basically doing the same thing, reading the data and writing it out somewhere, but the schema is different. So my answer is no. You can't write it in one job, but you can write it in two. Is that okay? And I suppose you could argue to write it in one, but I decouple things. So 2 jobs. So let's walk through this. This is a functional job, by the way. I read a database information schema. Get me a list of my qualified tables. I iterate through those tables. and I go read the information schema to give me a list of columns for that table. I save it using a set dynamic schema component. In memory, it creates an object of the schema definition that I've just constructed in memory at runtime. I then use the component to read the table because I now have the proper schema. Because I'm telling that read to use this newly created dynamic schema object. And I write it out to a file. Now here's the limitation of why you need two jobs. I'm writing it out to a fixed length flat file. So I have to dump the data out to a file. Okay? Now that file has a fixed length structure of all the data I've just read. And I can do this for all the tables that I want. Okay? Dynamically, in one job. In fact, this particular job reads through the TAC database and just writes out all the tables in the TAC. I don't care if a new table was added today, it'll still run. The reverse logic is all you need to do for the second job, which is still go get the list of tables, the list of columns, and save the schema object, but flip those two things around. Read the file, and then write it out to where it's going. So this is a great technique for moving data from Oracle to SQL Server, and everything stays the same. Now the information schema method here, and I'm going to show you a second way to do this. This method here allows you to tinker a little bit with your structure. You can change the length of your column. You can set a default value, a couple little things inside the actual dynamic schema that you may need that control of. But we have dynamic SQL components, like the T-MySQL table list. So instead of having to read the information schema, because heck, I don't know what that is, you can use, for most of the databases, we have a table list and a column list component. Just dump that in there. It's a simpler code, but it's basically doing the same thing. Go read my list of tables and iterate through them. Go read my column list, and then save out the dynamic schema. Go ahead and read my data, write it to a file, and again, the reverse logic will get you the write. Okay? The difference is I don't have those abilities to tinker anymore. Okay, I can't change the data type, I can't change the length, I can't dick around with it a little bit. So, I like more control, so I like the information schema method, but if you prefer, you can use the DB table list and column list methods. Or components, I should say. So, two jobs. And I can get samples of these jobs to our Talend customers.
Is this dynamic schema a new component?
No. It's been there a long time. Long time. Years. Nobody really knew how to use it. It's documented. It's there. Okay. We only have 3 left. Oh, God. I don't like this one. CDC, but necessary. Okay? Change data capture. We support CDC for a variety of host database systems, as you can see. That's a pretty comprehensive list. I don't know if you have a database that isn't on that list. And we have components that allow you to set up CDC techniques. I'm going to show you on the next slide what those are. So everybody in here has a CDC requirement, right? To some extent. There's always different ways to implement CDC. But if you're moving data from an enterprise transactional system into a data warehouse, for example, you've got to have some way of finding your delta. You have to find what data is new and what data has changed. So you can implement CDC techniques for that. MDM solutions might need CDC. And even enterprise to enterprise integration might need CDC. So you want to know that, yes, we can do this. And we have components to help you do this. And it's fairly straightforward. There's I think it's chapter 11. I think it's still chapter 11. I'll probably list that at the bottom here. But it basically takes the data out of the table and publishes it out. It tracks the changes, and then it allows you to manage the push or the pull of those data changes to your target. It does this typically with a trigger. Okay, in fact, that's the #1 CDC mechanism. Now, if you're using Oracle, we've also implemented the redo or archive log, which is going to perform better, or the Xstream. And frankly, I'm not an Oracle 12 guy. Anybody in the room? Can you tell me what Xstream is? This guy? Yeah, so it's a feature in Oracle 12. We've exposed it, we've implemented it, it's available. It's only available in Oracle 12. And there it is, yeah. If you go to the user guide, chapter 11, it's like 20 pages on CDC. Okay, so some customers don't even know that we support it. But yes, we do, and it's very robust, very comprehensive. It works. This isn't the only way to do it, but this is the most common when you're dealing with traditional relational database mechanisms. Okay? All right. Now there's 1,000 plus components in Talend. There's hundreds more in the Exchange, right? You can go out to exchange.talend.com and you can find all those components we didn't build that do things that you might need. Okay? So there is a technique for identifying that component in your Talend environment. You have to actually download it and install it. 2 steps. You have to go into the Preferences tab under Components and specify a common folder. So does best practices start coming up in mind? How as a team and where you want to store this in a common place. Okay? So you figure where that out is, because every studio needs to have that component local in his system. Okay? And then once it's been downloaded, it's available to anybody to install. Okay, so you'll have a list of available components from the Exchange, and you can install them. And once it's installed, that component will be added to your palette. And you can now use that component. Now that means your production environment also has to have it downloaded and installed, or you will generate an exception because it'll try and execute a jar file that it can't find. Okay? So that's all great. There's a lot of really interesting third-party components out there. I've used the Excel components for walking worksheets in Excel. But what if even that's not enough? I mentioned that Talend is an extensible product, right? You can build your own components. We've been using this thing called JavaJet, which is really a subset of Java that lets you construct your own components. You can even take the JavaJet from one of our existing components, clone it, and modify it and create your own version of MySQL input if you want. And do whatever you need to do. You add now your own Java code to the component to create your own IP, for example. I've worked for companies before I joined Talend. That's what they did. That was their business model. I'm going to create a custom component that does my business function, and I'm going to wrap it up in a component so that I can protect my IP and sell that. Okay. Why not? It essentially structures the thing just like any other component. You have a begin, a main, and an end, and you can use it to English. I don't remember what ZH is, but or French. ZH? No idea. Sorry, I don't know everything. I try. Okay, but help.talend.com, great place to go. Look for the create a custom component, and you will find information on how to build your own. Let's see, I think, oh yeah, one more thing. Essentially what you're doing when you're building a custom component is you're generating an XML file. It defines all the parameters and attributes of how you want your programmer to fill in the blanks. You know, when you put in a component, you go to basic settings and advanced settings, and you fill in the blanks. You have complete control over what is available and what is required for somebody to fill in so your component will run. So it's coupled with the JavaJet framework and this XML configurator, for lack of a better word. Now, I will tell you that JavaJet has limitations, and we have decided, I think, few years ago, to change that. And come up with a new Talend component framework, which is pure Java. Everything Java, which means you can even change the look and feel of the component UI yourself. So the new Talend component framework, and I think we're going to give it some product name soon, it's in pre-release now. We've built our Snowflake components with it. It's more robust, it's more capable, and there will be a webinar, I think it's September 7th, that Mike Verrilli is doing. He works on my team. We can get the link probably to the attendees if they want. If they're interested, he's going to show you how to use tcomp. So if that's something that interests you, you want to learn more about building your own component, we have a webinar coming up just in a few weeks on that. And that's the first of its kind from Talend. Okay, we got one more to go. How about that? Okay. Now we've been talking about how flexible Talend is, right? And how we can extend and expand and do all this great stuff. But if you really knew what was going on under the hood, it might blow your mind. Have you ever clicked on the JavaScript tab? You've got the designer tab, the code tab. I bet you, okay, admit it, you've looked at the Java code, right? You've clicked the code tab and you've looked at the Java code and you found out that you can't change it? You can't edit the Java code? That's correct. You can go back to the designer and change some things, it will regenerate the Java code. All good, right? Have you looked at the JavaScript tab? Anyone? It's basically XML. And this XML JavaScript defines everything you put into your designer. It's a flat file. Think about it. We have I know a guy who took advantage of this and through a metadata definition of all of the parameters that he wants and a skeleton, a template code, a job design pattern, or multiple job design patterns, he created an engine with Talend to go read that metadata and generate a JavaScript file based on that pattern, saved it to a file, sucked it into Talend, boom, his job is created for him. Automatically generate jobs themselves. That's pretty powerful. You can actually save this file out, manually edit it, load it back in, create a new job. Everything is based on the JavaScript. So if you really want to get sophisticated and really automate the process of generating jobs, and let's say you still need to create 3,000 jobs, do you really want to hire 100 programmers, or do you want to hire 10 really smart ones? Talend is that flexible. I'd rather you buy 100 licenses than 10, but still, you get the point. Okay, very great feature, nobody knows about, but there it is. Let's wrap up. There are some secrets. I think I've shared a few. I'm right. This guy would not hold me up. I haven't used it tonight without 3 legs. Use case is the first leg. What is the business purpose of the job? The technology stack, which is very comprehensive, and the methodologies. And we've talked about SDLC and DDLC. You have to know how you want to do things. Okay? And as I said before, the foundational precept that I think is number 1 at all costs is consistency. Just try and do it the same way. Yes, evolve, adapt, be agile, but be consistent. And you'll go a long way. This guy here, Pablo Picasso, I think said it all. Action is the foundational key to all success. All right, what does he mean by that? Do something. You can talk about it until you're blue in the face, but just do it, right? That's really what he's saying. I'm asking you to remember guidelines, not standards. We want to build jobs that are flexible, that will bend and not break, just by the silliest little thing. Don't create fragile Talend jobs. Don't create those big, massive, monolithic things that try and do everything, okay? And if you really are up to the challenge, even in a minimal way, create a center of excellence. My friend here has some thoughts about that, I'm sure. Talk to Adam if you want to know more about COE. Okay, my final slide, so I'm going to put this down. I'll take any last questions. Here's just a list of simple do's and don'ts. I'm sure you can come up with your own. but these are good ones. And that's it. I made it, huh? Thank you. No more questions. Wow, I stumped the audience, huh?